Hello, my little gangland homies. Um, today's video is something that should have gone in your head at GCSE level, to be perfectly honest with you. Today we are looking at what is meant by measures of central tendency, and I'm going to throw a cheeky little measures of dispersion in there as well. You're welcome. So we're looking at stuff, to be honest, that you have looked at in your GCSEs, maybe taking it slightly further, but you need to have a pretty good understanding about. Descriptive statistics. Descriptive statistics. So what we mean by that is essentially mean, median, mode, and you also need to know that that is what I mean by descriptive statistics. So annoyingly, this is not going full screen. But we'll do what we do. What are descriptive statistics? They are basically types of stats that describe the data, obviously. They tend to be quantitative data, so they tend to be numerical, but descriptive statistics is split into measures of central tendency and measures of dispersion. You need to understand both. Now, descriptive statistics is only one part of statistics. You also have inferential statistics, which is what we're looking at much later in the year, to do with that's more like stats tests, Wilcoxon's, Mann-Whitney's, significance, Pearson, Spearman's, chi-squared, sign test, all of these quite complicated stats tests that you look at uni. Now, we're only looking here at descriptive statistics, which, as I say, include measures of central tendency and measures of dispersion. On the left-hand side, you have what the measures of central tendency you need to know are. So mean, median, and mode. And these are things that you've looked at whilst you were in schooling. So what a measure of central tendency actually is, if you break down the term, measures of central tendency are measures that tend to be around the center. Measures of central tendency. So the word you're looking for here is average. So measures of central tendencies are different types of averages. Measures of dispersion are not averages. They are about spread of data. And the two measures of dispersion that you need to know are range, which you know, and standard deviation, which you probably don't know. The range is really easy, but we're going to go for all of these. Now, as you can see, at the top of this is basically what the mean, median, and mode are. And to be perfectly frank with you, I'm probably not going to teach you as such because you already know all this. You know that the mean is basically all of the values added up and then divided by the number of values, and that's a form of average. You know the mode is the most frequently occurring and the most boring as well. You know the median is the central figure going from smallest to biggest, for example. You know how to work all of these out. If you don't know, then I've just subtly told you. What you may not know are necessarily the strengths and weaknesses. Now, I'm not going to go through all of these because that's too faffy. It may not be page 37 in your pack. It may be something else, right? But I need to update these slides in particular. But one thing I do want you to think about, two things I want you to think about. How sensitive is the data and how representative is the data? So for the mean, median, mode, those are two central questions I want you to ask. And also, is it quick and easy to calculate? But mainly, it's the sensitivity and the representativeness. So what we mean by sensitive is, to an extent, how much does it take all the values into account? But also, how likely is that measure affected by outlier or extreme results? For example, I want you to imagine I find out the averages of all your groups and the heights that they have, right? So I go around all of your groups and I find out the mean, the median, and the mode of each of your classes, for example. Now imagine in your class, the average student size is something like 5'9", which probably would be about right. 5'9", 5'9", 5'9", 5'9". And that's male and female, by the way, non-binary, etc. Fine. Imagine someone joins your group and they are 6'8". Now, if you have a look at which ones would be the most affected, it would be the mean that is most affected. Why would it? Well, the mode would not change. If someone who is if we're talking about the average height of your group being 5'9", the mode is not likely going to change if someone 6'8" comes in. The median is not going to change that much. It will change slightly, but it won't change that much. It is the mean that is the most sensitive measure, and that is a good thing and it's a bad thing, by the way. It's a good thing because it means it takes all the values into account. It's a bad thing because it gets distorted by extreme values. So you need to know which of these are the most and least sensitive. You also know which of these are the most representative and which are the least representative. And again, to be perfectly honest with you, it kind of falls to the mean. The mean is clearly the best one. But the mean is the most representative because it takes all of values into account. The mode does not take all values into account. The median kind of does, kind of doesn't. So you basically need to know all of this. You need to know all of this. And I'm not going to spend my time going through it with you, even though that is technically my job. So there's a few things here. Yes, fine. Pretty simple. A couple of data sets, a couple of examples. But I also did want to go through measures of dispersion. So one thing that's important is to know is that the average does not tell you everything. The average does not tell you everything. Just as an example, what I say to I say this to my students actually. If I were to have two data sets, right, and let's say you've got 29, you've got 30, and you've got 31, right? That's my data set. What's the average of that? Well, it's 30. Okay, fine. But what happens if I had a different data set in this? And data set, I mean, it's just a set of data, really. Obviously, as I say that, that's pretty obvious. Well, let me show you a different data, right? Same measuring the same thing, whatever. Doesn't really matter. You get 1, you get 30, and you get 59. What's the average of that? Well, again, it's 30. But both of these are looking at averages, for example. Yet, even though they have much different data sets, it's coming out with the same average. So the point I'm trying terribly to get across here is average only tells you one level of the data. The other thing that comes into mind is actually measures of dispersion, how spread out the data is. So if you look at this data just here, that's not spread out at all. In fact, all of this data is actually spread quite neatly around the mean. Whereas if you have a look at this one just down here, the data is much more spread out. So average is not the only thing here. You also need to know quite a lot about measures of dispersion, including the range and the standard deviation. Now, the range we know, right? The range we know. It's calculated by subtracting the lowest value from the highest value in a set of scores. It's quick and easy to calculate, but the problem is it's not very sensitive. It only takes into account or only looks at the two extreme values. And doesn't really tell us that much. The standard deviation is much, much more complex. It's a single number, it's a single digit, and basically what it shows is, on average, how far away were the numbers from the actual average. On average, how far away were the values from the actual average. The higher the number, the more spread out the data set. On average, how far away from the average was each value? And it's one number. So that's the actual technical definition for, or formula, I should say, for standard deviation. You don't need to know this. This is also how you work out the standard deviation. You do not need to know this. All you have to be able to do is figure out and interpret that number down the bottom, right? What that means. So this is just a random data set, for example, fine. What does 4.73 mean? It means in whatever data this is about, each value was on average 4.73 away from the mean. The higher the number, the more dispersed or spread out the data is, the more inconsistent the data is, yeah, the higher the standard deviation will be. So I hope that makes it clear. I just want to go through because actually I don't know if, I don't. I'm just going to try something. I'm just going to pause this very briefly to find a piece, to find how this typically comes up in an exam. Give me hopefully a second. It might take me a little while longer. I'll be back with you in a single jiffy. There you go, one jiffy. Now I found a question in one of the papers. This is how this question almost always comes up. You're given a mean, you're given across two conditions, you're given a standard deviation across two conditions. Now, I do show this example stem quite a bit here, to be honest, but this is a stem about, how many verbal mistakes you make if you're talking to 5 people compared to if you're talking to 100 people. And as you can see, the mean is much, much higher when people think they are talking to. Look at her. Oh, she's eating a fly. The mean is much, much higher when people believe they are talking to 100 people compared to 5 people. And you can see that just here. The mean is 17.2 compared to 11.2 mistakes when people make errors when they're talking to 5 people. What I really want you to pay attention to are these two numbers down here. So remember what I said, the bigger the standard deviation, the more spread out the data is. One way to have a look at this as well, right? That is the mean, isn't it? 17.2, that is the mean. Remember what the standard deviation is. It's on average how far away are people from the mean. So actually, the standard deviation is 3.54. So the average is 17.2. You may have to pause this again and go over it. But the average is 17.2. But on average as well, people were 3.54 away from that. So the fact that this is 3.53, but this is only 1.3, suggests that condition B was much more spread out than condition A. If you have a look at condition A, basically that's quite a small standard deviation, meaning that on average, people were actually centered around this mean quite a bit. So most of the people in that condition scored around about maybe 9.5 to 12.4, for example. People scored around about that kind of level. Whereas for this one just here, people were much, much more spread out. How you would answer this question, because if you have a look at 6 marks, you would want to refer to this data. You would really, really want to refer to this data. You want to see that clearly condition B causes people to make more verbal mistakes because 17.2 is significantly more than 11.1. However, and here's the tricky bit. This is like the A star kind of level. You have to contextualize this number. So let me try explain this very briefly. This condition was more inconsistent. So how I would do that in this context is I would say, because the standard deviation is higher in condition B, there is a lot more variability in the mistakes that people were making. And actually, there are some people who made massive amounts of mistakes when listening to 100 people because maybe they got very nervous. But actually, there were quite a lot of people who performed significantly better than other people when in that condition, because the results were inconsistent. Some people did really well. Some people did not so well in speaking. But if you have a look at this one, everyone kind of did the same. I appreciate standard deviation can be quite complex the first time you hear it, but actually, I would recommend watching that again, trying to go over it again, try and wrap your head around it, because once you get standard deviation, you're in for a big advantage because this question comes up all of the time, all of the time. So can you make sure, please, that you are trying to wrap your head around standard deviation? If you don't get it the first time, don't be surprised. Not many people do get it the first time. But I would recommend you watch this maybe a couple of times, particularly around standard deviation. You need to know mean, median, and mode, measures of central tendency, and you need to know range and standard deviation, a measure of dispersion, but they all five of them come under the umbrella of descriptive statistics. So quite a boring one today. Not really much I can do about that. But as always, hope it was useful.